I'm gonna need more mic. Oh, there we go. Is it actually streaming now? I'm not actually sure. Let's see. It says I'm live now, but I can't see any chat or anything like that. Video details, analytics, view and control room. Oh, here we go. Connect streaming software to go live. Oh, there we go. Oh, I see it. Oh, that's cool. Hello. I was just gonna make a GAN, and you know, we're just getting started here, so you know, see how it goes. So far I just have some really basic stuff. Basic GAN. We've got it's called the DC GAN. Very old. It came from like, I think it's like 2014. It's like over 10 years old. So it's nothing too crazy. We're just trying it out on MNIST so far. Here's the results. Nothing crazy, as mentioned. But today I want to start going through StyleGAN 3, because StyleGAN 3 came out in like 2022. I haven't really done anything with GANs in a long time, but I had a really good idea. But it's going to require me to implement StyleGAN 3 and then implement all the changes I want to make to StyleGAN 3. So yeah, I guess let's get this show on the road. I kind of want to have some fun with it, but first, before all that, I've been through with TensorFlow. I no longer use TensorFlow all that much. I don't hate it. Just PyTorch is better, as far as I've seen over the last couple of years. Like, it's constantly being improved upon, significantly better. It's what everybody seems to use. It's what ChatGPT seems to be really good at these days. So that's kind of my justification for that. So I just implemented a DC GAN. Honestly, I didn't even hardly make this code at all. This is all almost entirely ChatGPT. But yeah, it's easy peasy. So yeah, I guess let's get into it. So I really just want to make this into StyleGAN. I think that'll be the easiest way. If we just make all the parts of StyleGAN 2 that are still used in StyleGAN 3, then we can just go from there. So StyleGAN 2 comes first, and then StyleGAN 3, and then maybe some StyleGAN XL. I know that came out a couple of years ago. And then on to some other stuff. Projected GANs are a pretty intense thing. As of lately, I haven't actually done anything in a couple of years here, so we'll see. Let's get started. This works. We've got plenty. Here's epoch 7, 8, 20. It works. It's not great. I don't really care about the quality yet, because that's not what we're here for. We're just here for something that runs at this point. Cool. Let's take a look. Now I want to make a new file called modules. And what I'm going to do first is I'm going to make, you know, this is the tough part. I actually don't know what to make first, because there's obviously so many ginormal things to make. I think first of all we want to scrap the sequential thing. It's not something I like. Okay. Let's make I could do residual as just like a block, and then put it all up. You know, why don't we do this? We're just gonna make some really simple. We're gonna make some really simple modules here. So we're gonna have a generator block. The generator block's just gonna be something super duper simple, but it's also going to output. Okay, we're gonna start with a convolution block. It's gonna be a convolution 2D or transform. It's gonna have some number of hidden layers. It's gonna have an input dimension, output dimension, okay, how does this work again? In channels, easy enough. In dimension. Next is going to be out channels, out dimension. Next is going to be kernel size. Sure. Oh, I see. Kernel size. I'm also going to install black over here. Probably usually going to be 3, so I'm just going to put it as 3. Stride. It's usually going to be 2. For some reason here. Yeah, there we go. Kernel size. Stride. And then finally, it's going to be padding. I don't think we ever need any padding. We could put it in there just in case. Not 90. I should probably watch chat just in case. Cool. So this is super cool. So we're gonna have all those things added into there. We want leaky ReLU, because everything else is bad. I've always been a bigger fan of 0.2 than 0.01. You know, we'll just leave it there. Okay. What happens when you go forward? You have a torch tensor. I always like calling these IMP for input. So you're going to want to use the convolution dash normalization and then leaky ReLU. Let's call this L ReLU. ReLU feels like it takes up too much time. Then we can return that. We could write this all on one line, but I actually prefer it like this. I think it looks better. Okay, so now instead of here, let's add self.blocks module list. We can just start importing. So this will be a generator block. I think the input dimension, what's the input dimension here? Z. Okay. 128. Kernel size is going to be 7 for this. And 1. This is the only one that we're going to have that's going to be super weird. Just because this is the one, so I start with a 1 by 1 by like 64 or whatever and then it just blows it up to 7 by 7 so that we can then go 7 by 7, 14 by 14, and then 28 by 28. Oh, my audio is really low. Here, I can up that here. How is that? I hope that's a lot better. Hello, hello, hello. Okay. Let me know if that's better or not. Okay. So we can add a couple more of these blocks. So this should be 7 by 7 by 128 output. Oh, perfect. Thank you. So that goes 7, 7, 128. This will be 14, 14, 64. And we're going to have one more because we want to get it to 28 by 28. Let's go from 64 to 32. Oh, we don't want these either. Kernel size of 4 before? Yeah, that makes sense. So let's go 4 and 2. So now we're at 28 by 28 by 32. Wow, absolutely ginormo model here. Kind of crazy. All right, and before we just had it where it would transpose, but it would just transpose everything all at once, which I'm not a huge fan of that. I'm actually a much bigger fan of just one convolution right at the end, right at that last like highest fidelity sort of thing. So I'm just gonna add that here. So last, I'm gonna call it a fully connected. Linear, here we go. In features, we're gonna get 32. Actually, we should just do a convolution, hey? 2D convolutions are actually much, I imagine they've been optimized in some way. 32, we want 1 out channel, kernel size of 1, stride of 1, padding none, we don't need any of that other stuff. Cool. And then we can just apply tanh later. Or we can just add it here. That's fine by me. Okay. So now when you get this input Z, that's going to be our noise for block in self.blocks. Let's just set X instead of Z. X equals block Z. There we go. So now we're running through all of these blocks. We want to run it through the fully connected and the tanh. We might as well do those two right at the same time. Cool. So now this is our fancy dancy generator. And now we can open this up. Let's get our discriminator block. So I basically want to do the same thing but backwards here. I'm going to format these things too. I think it's going to auto format actually. I'm just going to copy this code. Don't tell myself I'm copying my code. Here we can basically just do the opposite. I think we just convolve, batch norm, leaky relu. Easy peasy stuff, nothing too complicated here. This also shrinks it. I don't like that. I'm not the biggest fan of it, but I guess it'll have to do. Okay, I'll call this discriminator block. Cool, and we can append them one at a time. This one will be 1 to 64. I'm not the biggest fan of using strides at all. I know that they do it in DCGAN and that's fine, but I'm a big fan of like average pooling and stuff like that. Everything just feels so much smoother and not aliasing, but maybe I'm also just focused on that because I'm thinking about StyleGAN 3, which is all about not having aliasing and being equivariant, as they say. This also only has 2, but hold on, let me count. I might just be bad at counting. 14, but oh, I see what's going on. So you really only should have 2, because if you have one more, then it'll go like really far down. However, I don't want to do that. I'm not a huge fan of that, and I think that's a stupid, silly thing. I think they should almost always be precisely the opposite of the architecture of the generator. I feel like when they mirror each other, at least to start, I think when they mirror each other, they do a lot better. So if we were mirroring here, this would be, well, first of all, it passes in 128. Let's just say we want 128 as output, but we want to now shrink it down to just 1. So now this would be 1 by 1 by 128. Yeah, that looks good. And then I think I just add 1 linear. Because when we call the model, what we can do is we can just take this output and we can just chop off these 2 dimensions here. We can just squeeze out those dimensions. I forget exactly what the thing is. I rely on ChatGPT heavily though, and ChatGPT writes all my code, so it doesn't really matter. We're gonna want one output, and it's gonna be a sigmoid function. Soft.sigmoid equals neural network.sigmoid. I wonder what log sigmoid is. I didn't actually look at that. After this, maybe I'll do Wasserstein GAN loss. I've never used it. At least not in PyTorch. I think I used it way back in the day when I was still doing GANs quite often, but I haven't used it in a long time. So this is basically going to be the exact, almost precisely the same as the generator now, which is nice, very standardized. It's the kind of thing you like to see in your code. I call this head, but I can call it FC. And this will be INP. Because like I said, I like INP. So now we've got that down, except this. So this is the tricky part, is that this has to be squeezed. I'm gonna ask ChatGPT really quick. I'm gonna ask for batch size 2. All right, let's see. You can use .view, .reshape, or .squeeze. Cleanest option is using .squeeze. Okay, let's just use .squeeze. X.squeeze. Squishy GAN outputs. Hello. Squeeze. Okay, so this should have one output. So your output from here should be like batch size 1, hey? Also, these should definitely be going down here. I don't know why I've put those up there. but this should work. So now if I just run this, it's a bit naive, but if I just run this, will it just work again? I'm gonna delete all these. Nope. No module name training. Oh, see, and that's because I have everything in this training folder, so when it auto imports stuff, it does that. And I have no idea how imports work. I am not the best at Python. I'm not the worst, but you know, could be better. Transposed weight size of 128, 64. Got 100 channels instead. But why? I only need one squeeze. Is that true? I thought this came out as 1-1, like you have batch size 1-1, 128. So then you squeeze off the first one and then you squeeze off the second one. I thought that was the case. But honestly, I don't know. I haven't done this in quite a while, so you may very well be right. But where's this one coming from? Because this comes in the generator before anything even happens. It's expecting 128 channels as input, but it got 100 instead. Is that true? If so, that's going to cause problems. Huh. Well, I'm going to keep it for now and see if this generator works. My question is, okay, so it's like, it's running through, and it's saying it wants an input of 128, 100. It's supposed to get 100 as input. Where do we generate the noise here? Oh yeah. We are on the way to StyleGAN 3. I am just a little bit slow here. I'm trying to do it from the ground up, which means that at least today we might just, depending on how things go, I have to go pick someone up from the airport in like 2 hours or so. So I might not have the time to get all the way to StyleGAN 3. It's been a while. I'm not as fast as I once was, and if I keep getting problems like this, who knows how long it's gonna take. Okay. I think I'm tripping because, like, I swear I'm passing in. My in dimension is the Z dimension. Got 100 channels. Am I? Oh, you know what it is? Yep. It's because I did that. So I was just trying to pass in the input over and over again. Okay. Okay, let's see. Let's see if that one guy is correct about the squeezing. Calculated padded input size per channel 5x5. Kernel size can't be greater than actual input size. Okay. Convolution of input. Okay. What's my kernel size on this? This is the first one being used. I'm not running into the same thing as last time because I'm just copying over my input to X, and then I'm just running all these on X. So I believe this is a strange one. See, it's just been so long since I've done this. God. Padded input size per channel, kernel size is 7 by 7. Oh, wait. Stride. I'm setting stride as 7, but the stride should really be 1. And there should be no padding at all whatsoever. Yes, precisely. Line 37, actually, great call out. Okay, it says training. And doesn't do it. Okay. 128. Padded input size per channel. Wait a second. Is this striding too much? Because this should be... Oh, I think it's because I need padding on these things. Because these things are not... These things don't have any padding. And so when it shrinks it down, it'll shrink it down too much. Like it'll shrink it down by like an extra pixel. And then if you do that twice, the input size will be 2 down or 1 down. Something like that. But I believe that if I just add padding back, okay. 16,000. Why is it 16,000? Yeah, because this has to be that. But why is it 16,384? What's special about that number? Is that divisible by 7? It's not divisible by 7. It's divisible by 128, and it's 128 squared. So it wants to go from 128 to 128. Is that where this is coming in? Because this should output to this x as just 128. Maybe I do just need one squeeze. Hold on. No. But why? Why? It says it's on the linear layer of the discriminator. I'm going to copy this one in ChatGPT, I think. New chat. Boom. The issue is here. This assumes the spatial dimensions are at dimension equals 1, which they're not after the final. Oh, what? Is it not? Oh, are the channels first? Is this a channels first thing? You know, if that's true. Okay, so I just gotta take off the last 2 layers. That's crazy. Whenever I was working in TensorFlow, it was always channels last. Oh, now we got a bigger number. Okay, that's cool. That's cool. I should actually read what this says. Update your forward method to... Well, it says to just do this. Let's just try. Kapow. If this works, I'm getting ChatGPT Pro. Yep. No, I didn't think so. That's crazy. Why would it lie to me, honestly, at this point? Insane in the membrane. Is this not... Is this padded too much or something? Is it like too big? That might be it. If it ends up being like 5 by 5 by 128. No. Yeah, so it was that, but... Is there a way to get summaries? Do I have torch info? No. Yeah. So, torch info. See, I used to use the debugging tools for this stuff, but it's the debugging tools really slow down whenever you're doing something that's not like basic Python. Like, for example, if you're making like database connections, GPU stuff is really slow. A lot of disk operations, there's so much overhead in the debugger that it doesn't work super well. Like, it just goes really, really slow, especially when you're like loading in. Okay, let's see. Oh, how I did that. What I want to see is just see, and it looks like it's fine. It looks right. Does this? It just has a linear, but then it just breaks. All right, let's switch to just the CPU now. I think I will use the debugging tool. Add config Python. It's just going to be a current file, I think, that we'll use. I guess these aren't huge models, so debugging tools could be the move. All right, are we gonna actually? Would be. Do I have to actually press this? Is it just running it now? Okay, we're just gonna wait until it goes forward once. Does this have a shape? Oh, I don't actually know about that. The VS Code breakpoint 2 that Alexa Gordish, sorry about the pronunciation, used to explain whisper text to speech architecture and code. I haven't seen that. Hold on, I'm gonna write that down so I can look it up later. But for now, I guess this'll do fine. I would like to see the shape of this. Here we go. 128 by 1 by 1 by 128. That's fine. Okay, what does our X look like now? This is a tensor. All right, this is after everything is done. We're gonna have a shape. Shape is 128 by 128 by 1 by 1. Wait, what was our input? What's our batch size? Yeah, okay, that's fine. Oh, oh, thank you. Oh, that's the whole title. Perfect. I'm gonna drop that one down. Very cool. Thank you. That's gonna be in handy. That's gonna come in handy. Let's see. Shape is 128 by 128 by 1 by 1. Okay. And now our shape is 128 by 128. Okay. Now if we step into this, oh, it's probably got an error, doesn't it? Wait a second. Did that work? Wait, so it worked on that one. Wait. Strange. Okay, wait. It worked on the real ones, but I would make a bet that it's actually not that's the problem. I would make a bet that the generator is giving the wrong outputs because it probably has the same padding problem. Where is it? Fake. Here we go. Yeah, it's like 34 by 34. Oh, that doesn't sound like it's correct. Okay, so what's going on here? I don't know. Because here, okay. But the padding, if I put on a padding, it's gonna add even more, right? Is there like a reverse padding? Hold on. So ChatGPT lied. It didn't know what the actual problem was. ChatGPT, I thought you were my friend. It's outputting 34x34 images. Here, I'll let you guys see too. Okay, so current layers outputs 7 by 7. And then, yeah, so it's 16 by 16 because you have to add this much. Use padding equals 1. But why does padding equals 1 work? That doesn't make much sense. I mean, like, I'll trust the process for sure. But, like, in my mind, padding adds extra stuff to the sides, right? So it shouldn't do that. And it's silly. And it's not actually a bug that I made. It's a bug that something else made on my behalf. I'm just kidding. It's not true. Definitely my bug. But look, it works now. Okay, that's cool. Wait, I kind of want to see if the squeeze thing. So I know that it's like this, but if I squeeze twice. Yeah. But I do like this better, actually. There we go. Okay, let's try that out. All right, I have my folder here. It is empty right now. Currently, Windows does this thing where it like caches your photos. So when I open up the photo, it's going to show what the old run looked like first, and then it's going to show what the new run looks like. Like the new output for that epoch. It's also slower, a lot slower. Before this was working at significantly higher batches per second, and I'm not sure why. It is being so slow. Probably because I just took this. Like a sequential model is like super optimized in order to just run things just direct, just straight. And when it compiles together before you train it, it like makes some of those optimizations, and then I think by changing this into you know, feed forward by going through the different things, it's not pre-compiling all of those graphs together. I don't know, some stuff that I'm not smart enough to know about all that down there kind of stuff. I like to stay on the upper levels here. Although it would be cool, I don't know, if you wanted to make CUDA stuff. I want to make CUDA kernels. I think that would be a really neat thing. And I know that StyleGAN 3, one of the reasons why I didn't implement it a couple of years ago, partly because I was kind of getting out of the GAN stuff because I was moving into an industry job. But I was it was partly because one of the modules that they have for it is it's a custom CUDA kernel that would be really difficult to implement on my own, so I don't really like that. This is interesting. Nothing good yet, of course. I mean, we've only gone through one epoch so far, and you know, I guess this is just how it goes so far to start. Now we just kind of wait. Just kind of wait for it to train. See what happens. You know, I didn't know about TQDM until actually just a couple weeks ago, but it is like, it's a Python library for progress bars, and then you can put things in your postfix like this, like your losses for your different models and stuff like that, and it's really, really nice. I think it looks beautiful. I think it looks wonderful. All right, they're starting to really sharpen up now. It's starting to look pretty good. You're starting to see some like real digits now. Like you got a 6, you got a 4, a 1, a 0, an 8. You know, those sorts of things. It's pretty cool. Nothing too crazy yet though. It's of course we've just begun training, and oh, well, I mean, I wish that this was a little bit faster. I kind of wonder if the stream itself, if OBS and stuff like that are taking up any of my GPU. Oh, you know why it's taking so long? Oh my goodness. It's because when I was debugging, I just forced it to use the... Oh my god. I was forcing it to use the CPU. That's why it was taking so long. It's because it wasn't using the GPU because I wanted to debug it earlier. Look at that. Wow, it's crazy. Once you start parallelizing these things, it starts going, what is that, 15 times faster or something? That's crazy. Okay, well, I guess sort of make you guys wait for all that time. But stack the images into a 16 by 9 grid. Well, it's 8 by 8, but like you want me to stack them into a 16 by 9 grid so I can make them like bigger? Here, let's see. Oh, I can just do this if you guys want them to be larger. Oh, I have to actually transition here. Ooh, that's fancy. I am no pro streamer, and so I find this stuff fascinating. But all right, look at that. We're on to Epoch 5 now. It's huge. Everything's coming up. Everything's coming up. Yeah. You know, that's not a bad idea. What's 16 times 9? 16 times 9. It's like 160 minus 16. It's like 144. Let's get 144 outputs. I also use Cursor. Cursor, it's kind of nice. I don't pay for it. I find that if you just put in your own GPT keys and stuff like that, it's much nicer. All right, let's go back here. Here's the last one. I'm gonna delete them all. Cool. Yeah, that's going really fast. While that's training up though, I want to do the first thing from whatever it's called from StyleGAN 2, which is to replace the growth. The growth is an interesting thing. So what happens from there is each of these just has like another layer where it outputs, and then they all add up to the final output, so that the lower layers can output stuff and the higher levels can output stuff. So I'm gonna implement that really quick, but in the meanwhile, just 1 second. Here is the images. Boom. That's gonna be so much more good for you guys. I think it looks pretty nice. I don't know if you guys can see my cursor or not. It looks pretty nice. You can start to see different digits being output. Some of them are kind of weird. Like, what's this one down on the bottom here? Or like this 5 is not like a realistic looking 5, but you know, I think as it goes along and it trains more and more, it obviously will get better and better and better. Like, you can start to see where it starts to make things up pretty well. Also, did this... Because before it was like... It was really specifically like... It would like track from image to image. It would be like the same latent space, but it doesn't look like that now. It doesn't look like those match up. Because the changes are typically more subtle and gradual. But like here... Like this one on the right side here... Below, it's like 5001 on the very right, is now a 2, and all these other ones are pretty clearly different digits. Also, I just want to say, like, what's this? What is that? It's like a bad, but interesting at the very least. Oh, okay. So, yeah, I want to do that for the generator. I want to make, like, I want to get rid of growth. I mean, we don't have growth, but it would be interesting to have those layers. So, let's go self.out1 equals, I think these can just be convolution, and outs 0, 1, kernel size 1, and then we can just add them all up. The final output will be all of them just added up. And this one will be out 3. If I remember correctly, the growth architecture is like a add scale, add upscale convolution, right? Hold on, let me think. Yeah, so it's like you convert to RGB. Here we don't. I have RGB obviously, but like here you. I'm just trying to think. I think the convolution comes first, and then you just upscale it, and then you add them all together, and then you do your activation right up at the end, kind of thing. Yeah, because then, oh right, yeah. What's the thing for? Let's do dot sequential. And this you can just, yeah, you can just keep adding. Dot upsample. Upsample by linear 2D, is that correct? Size? I think it might be upsample. bilinear 2D. I think this is the one. I think this is the one. And then scale factor for this one will be 4. Scale factor for this one will be 2. You just want to go 2. And the last one will just be that. Okay. So outputs dot append self dot out 1 of x. Oh, you know, and now see, this is the thing, is that you have to because unless you want to use out 2 and out 3. Okay, so instead of this for loop, what I'm just gonna do, I'm gonna do self dot blocks 0 that, and then we're just gonna go boom boom, because I'm too lazy to do it any other way. And this is 3. And I'm just going to tell cursor to do this for me. Instead of x should be the sum of puts. Oh my god. Torch that stack outputs some dimension 0. No, that's not right. That's not right. The dimension should be. Is that? No. That sounds right. I guess it puts it in dimension 0. Yeah. Fine, whatever. That's fine. I'd rather it be dimension -1. I don't know why. I don't know if it helps at all or anything. Oh, here. We've got more images for you guys. Kapow! Wow, isn't that fancy? Look at those numerical digits. Now, theoretically, transition back there. Theoretically, this should work completely fine. The first time, and there will be nothing wrong with it. I just gotta run it, and then it's just gonna be like, wow, you did such a good job at coding this the first time that nothing. Yeah, never mind, my bad. Convolution 2D got 64 channels instead. But why? What happened? Looks really good. Thank you. Expected input to have 128 channels, but got 64 channels instead. But I'm doing this the same way. What do you mean? It probably has 64 channels. I think this thing is it's bugging out. It's PyTorch's problem, I think. PyTorch buggy. I'm calling it now. Which is it actually though? It's in the generator. Outputs dot append self dot out 2. Oh, never mind. I take back everything I said negative about. Everything negative I've ever said about PyTorch, I take back. It was all a lie. It was never true in the first place. I'm ashamed of my lack of candor. Yeah, I noticed. That's a shame. Also, I've got a like a 30-second delay, I think, on my stream, just in case anyone wants the automatically generated closed captions. I turned that on, but I had to have the delayed stream. So if it takes me like 30 seconds to respond to a chat or something like that, that's gonna be the reason why. But thanks for sticking around, by the way. I appreciate y'all watching watched me fail to make GANs in the same way as I used to be able to. You know, it looks like, man, I wish I had kept the old run. This looks like it like converges really quickly. Like much quicker than it used to. But maybe that's just my own personal bias. I don't know. See, it's so hard to tell because like I'm not gonna whip out an FID score or like a precision recall score just for this kind of experimentation. So it's just got to be all by looking at it, right? Oh, here's the look for you. But no, it's kind of crazy. I think it does converge faster like this. But okay. Oh, fair enough. Fair enough. Oh, I guess you can see my time, hey? My time zone. Interesting. Cool. Okay, so these are the current images. 5, 7, 8, 0, 7, 6, 3. See, these are looking pretty good. There's a couple ones like this that are just not digits, but like for the most part, it looks like got 3, 9, 8, 4, a badly written 6, or a badly written 8. Yeah, I didn't even know that you could enable the seconds here. Oh my goodness. I didn't even know that you could enable the seconds on this, but I learned that like 2 months ago. Like I have years of experience programming. I can make neural networks. Did not know that Windows could show seconds. It's kind of crazy. Could you use a harder data set like Fashion MNIST instead? I actually kind of wanted to move to a colored data set like with RGB channels and stuff like that next. So I'm thinking actually instead of that I'm gonna do Sci-Far. Would you also be happy with Sci-Far? Because I would love to do Sci-Far. This data set is too easy. Sci-Far 10 data set. Oh, it's so interesting to me when these things fail when I change code, but it spawns different workers for the data sets, and yeah, it's cool. Sci-Far 10. Have you heard of Sci-Far 10? Sci-Far 10 is an interesting data set. It's still small images, but it's definitely more diverse. So it's got 10 different classifications. It's meant for image classification. We've got 10 different things here. And so you have all these images of airplanes, automobiles, birds, cats, deers, dogs, frogs, horses, ships, and trucks. All the things that you could possibly want in your life. And so it's got a lot more diversity. You know, the ships are like, there's 20 different orientations of a ship that you can take a picture of it in. There's like 100 of a truck, 200 of horses, 1,000 of frogs, a bajillion of automobiles, you know, and there's so many different like things like that. So it's a good data set. It's a nice one for testing things out. It's also 32 by 32 and in color, so that's gonna be nice for this. Elsa Bedroom is I remember generating way back in the day on Elsa Bedroom. It's quite a nice data set. It was one of those first ones that actually seemed like it had a use case, because like as much as small little 32 by 32 colored images is nice, nobody's using that for any use or case or anything like that. Whereas like if you see a picture of a bedroom and it's like a 256 by 256 image, then you're going to be like, oh, this looks like a nice bedroom. In fact, maybe I want to set up my bedroom in this way or something like that. It's an interesting one. But all these are just really good for you know, testing out the data sets and stuff. But I forget how to do this. Sometimes it just genuinely works, which is nice. Yeah, like this it works. It's the same thing. What are we doing here? Normalize. I forget what this normalize does here. Like what precisely it does. So I'm going to ask ChatGPT. I find ChatGPT is such a controversial thing. There's so many people who say like, oh, like it's going to make it so that programmers can't program as well as they used to be able to or something like that. But I think that it's really up to the individuals who are like, when you're learning to program, you need to learn to program and stuff like that for sure. But like, I think it's such a good learning tool. Like for this example, like I didn't know exactly what this does, and now I'm going to learn. Input channel minus mean divided by standard deviation. PyTorch image transform that normalizes each RGB channel. So in this case, 2 times input minus 1. Oh, so it goes from 0 to 1 to -1 to 1. I don't know why it does that. I don't like that, but whatever. Whatever, not my problem. Not my circus, not my monkeys. So we need to change this. This so far takes in 64, something like that. And then it starts with 7 by 7, which we don't want because 32 is not divisible by 7. Sapphire 10 took way much longer to converge compared to Fashion MNIST based on my experience. Yeah, oh yeah, absolutely. So we're starting at, okay, we don't need these modules anymore. We kind of know what they do. Let's start by 4 by 4. So we can just do that, 4. This should have a scale factor of 8. And then this is just going to double it. So this is going to go 8 by 8. This will be 16 by 16. And this one actually needs to be a bit more like that. Now I'm going to try not to make the same mistake I made mere moments ago. Out 2, out 3, and now we just need one more for out 4. Do I want to have 32? That feels so small. Let's do this. And then we have to change these ones too. 64, 32, yeah. So now this should be 32 by 32 by 32. It's going to be slower. This model is going to be a lot slower, but that's going to be completely okay. We're not worried about speed too much here. And I think this part's going to be so easy because it's literally just going to be out 4. We're not going to upsample, which means that we can actually just do this. Beautiful, wonderful, amazing. And this should be called out 4. So now we have 4 different outputs during the growth. It's going to output properly. You know, it looks really small on my screen over there. I'm gonna up the font size for you guys just in case. What GPU are you using? Oh, using ChatGPT for hard stuff, sure, but replacing easy tasks with ChatGPT can affect your cognitive, according to MIT research. Yeah, it's interesting. Yeah. I don't know, I've always been a big fan of automating away the easy stuff a little bit, but only if you know it and only if you could like replicate it again, you know? Like there's certain things where like I don't remember the output or the syntax or something like that. And so getting ChatGPT to tell me the syntax is like super nice because it just obviously it knows, right? But in some cases obviously like, you know, you can rely on it a bit too much. Um, it all depends. I think it just, as long as you're using it responsibly and safely, um, in the sense of like you're not just offloading your entire cognitive load to ChatGPT. It's I don't think it's too bad of a thing, and I think that ChatGPT stands out among every learning tool as being just one of the best learning tools out there possible, because it's one of the only ones you can sit there reading articles for hours, but you paste that article into ChatGPT, you start asking a question, suddenly you have a much deeper understanding and something to bounce ideas off of, you know, and it just makes learning, it makes learning more fun too, especially if you give some custom instructions to ChatGPT to make it really fun. What GPU are you using? I'm using a RTX 3060 Ti, I believe. Although I was thinking I might replace this one here soon. But I guess we'll see. This was okay. So we just need one more block. So this one will be 16 by 16 by 64. This one will be 8 by 8 by 128. This one will be 4 by 4. We need to change this as well. 421 by 256. We're gonna make it. It's gonna be huge. It's gonna be so huge. You guys have never seen a discriminator bigger than this one. Then we're gonna do 256 by 256 by 256. We're gonna do one. We're gonna do strides of 1, 4. I forget how I did it up here. Stride of 1, padding of 0. So I believe that is fine. Yeah, Kaggle and Colab, especially like some of the older ones, like what do they use? They use a T4 on Kaggle and Colab. I think they use the same one, but it's not enough, right? So it's I hear you on that one. It's not enough to do most things. Like obviously right now I'm using a small model. This one might be fine on a T4, but you know, as soon as you move up to wanting to implement full StyleGAN stuff, then you need a real GPU sort of thing. And it's strange because like I find that I'm also just never happy with the size of GPU that I have, because it just feels like in the last 2 or 3 years, one thing that made me leave, or not leave, but like made me want to stop making GANs and stuff as much, is that you just got scaled out. Like all of the models, especially the big like ChatGPT size models, you're never going to run any of those on your local PC. Those things have trillions and trillions of parameters. Like those things are, even just to download the model is going to take like terabytes, right? And then to try and run it is just absolutely impossible. So if you ever want to compete on any scale to any generalist model, you're not going to be able to do it. And then the generalist model scaled so much that you just can't compete anymore. It's just impossible. Because even on your specific task, if I try to make a Pokemon image generator, I used to make the best Pokemon image generator in the world because I downloaded my own data set. I made a couple changes here and there. Nobody else was really doing it, and you didn't have these massive generalist models that can just do it really well. But now you have these massive generalist stuff that just these massive models, they can do everything well and fine, and it's because they scraped all the data off the internet and they took it all and now they're just they beat at your own game. You gave them too much data. Well, everyone did, I guess. Not that I think it's a problem, because it led to things like ChatGPT and all these really nice image generators, which you know, I use those things on a day-to-day basis. But it just feels like you got like hobbyists kind of got scaled out of machine learning, except for in very niche things. So I think incorporating ChatGPT to like SQ3R learning strategy might be great. Like read and try to learn the text source first, and then use ChatGPT to answer the question. Absolutely, yeah. I sort of did something like that. I'm confused what you mean by SQ3R, if that's a typo or if that's like a thing that I just haven't heard of yet. But I'm trying to figure that out. But I did that. I've been uploading papers to ChatGPT. Like I uploaded the StyleGAN 3 paper to ChatGPT today, and then I was asking it for like tutorials. How are these things working? You know, if like when it uses projection or something like that, what does it specifically use about projection? Or I guess that was StyleGAN XL. That question was, but it was interesting. Okay, this maybe work, maybe doesn't work. I guess. Oh, I guess I also have to actually change the data set. That's funny. Sci-Fi 10 dataset. Pin memory true. Why are we using pin memory 2 if not for real? Non-blocking true. Okay, no, that's fine. Also, biggest thing, I found this out recently. If you use a CUDA for your stuff, you should always pin memory true, because that just like keeps it in the same place in like I believe your CPU memory, and then non-blocking to transfer it over to the GPU. That way you can start transferring it over ahead of time. This one change actually made one of my other models that I was using at work, it was like 4 or 5 times faster or something like that after I made that one change, because the discs the disk and the moving memory over the overhead to move it to the GPU took incredibly long. It was kind of crazy actually, just how big of a difference it had. All right, torch. Okay, so we've got that. I believe our output should also be 3, shouldn't they? 3, 3, 3, 3. Okay. Stack them up, add them up. Run through 10H. Okay, and then I think this is it. I think this is SQ3R is a 5-phase learning strategy where you skim through the text sources, then write a question about the said sources, and then read with the intention to answer that said question. Interesting. And then recite from more stuff, memory, and periodically review the material. Interesting. Yeah, I'd never heard of that. I'm gonna write that one down too. SQ3R learning strategy. Interesting. Thank you. That's. I'm gonna look that up. That's sweet. Because that sounds like it would be effective, at least for learning stuff like papers and stuff. Would be sweet. Oh, and the discriminator needs to read in 3 as well. Because this input's going to be 3, so we got to start with 3. I think that's going to work, and nothing's going to go wrong, and everything's going to go right, and nothing could possibly go wrong at all. Oh my god. Oh, never mind. That's just... I got really excited. I was like, oh my god, it's just immediately working, and it's working so fast. No, it's just downloading data. That's all. 1.7 million parameters. That's crazy. What a huge model. Oh, am I going to run out of CUDA memory? No, but it is using... Oh my god, no way. There's no way. But I bet you the output images is going to be... No way, it actually worked. That's actually insane. I can't believe that worked. Why did that work? I don't know. Bamboozled, bambozzed, bamboinkin. Your sound is really low. All right, let's see. You know, this is interesting. It's fascinating how it has like color schemes between, and this is something I guess you don't really get on I wish this would zoom in by default. I wish that it had, or sorry, I was just talking about. It's interesting that it has these color schemes by default. It like each training step, it's like just for this step, it's all yellow, and just for this step, because of the way that the gradients are moving, it's all red and purple and stuff like that. Interesting. It looks like it's doing pretty well. No AUB out of memory. I used to train my 64 by 64 GAN on 2 gigabytes. Yeah, it depends. The reason I said that was just because I've got a batch size of like 128, which is pretty massive. Wow. This actually doesn't look too bad, but you can definitely see, so this is the interesting thing that's going to come when we start getting really into the StyleGAN 3 stuff, is you get this aliasing effect where, because of, and it's really, really bad with DC GAN, and then it gets better and better and better as models move up. One thing that you're really going to notice is the you've got these like really firm, set in place, like grid-like patterns. It's interesting because it's going to take the pixel positions from those lower layers and it's going to change them and move them up. But all the strides are going to leave these things in the same place. So you get this like grid sort of net-like pattern a little bit, which is called aliasing, because then you have, well, I don't know what the word aliasing means really, but I know the vibe of it, and I'm sure it's right because they used it in their paper, but you get these weird grid patterns, sorts of texture things, and it doesn't look very good, but since they're both using the strides, then it is actually unable to detect these things. So even perceptually, even though perceptually to us we can see the weird strides and nets, the neural network can't see them, which is fascinating. I think it's kind of crazy. But anyways, it looks like it's doing really good. I don't know, it's got a lot of diversity here. It's looking like it's generating some, I wouldn't call these realistic, but they're certainly they're certainly doing well. EMA, yeah. EMA, one of my favorite things to do on models like this. I mean, it just makes it so much smoother. I remember my first time implementing EMA a couple years ago, and I was just shocked at the difference because you don't have all that noise from between steps that happens in the model, so you don't have all these crazy things happening to it, right? You know, maybe that's the next step. Maybe our next step is to create an EMA in our training loop. In fact, I like that idea so much. I think we should do that. Okay, so while that's training, we can do an EMA. Now, I don't really remember how to do an EMA, so I'm just gonna cheat a little bit and ask ChatGPT for a quick little refresher on it. I'm just gonna paste all my code in. To implement exponential moving average of the generator weights in PyTorch, you maintain a shadow copy of the generator. Okay. All right. I'm going to follow this tutorial step by step, but I'm not going to tell you guys that I'm following a tutorial because I'm going to keep it hidden so that you guys think that I'm just making up this code all on my own. We're just going to move down here, GMA equals copy dot deep copy. Oh, right, I forgot that when you edit code and you have a syntax error, it just breaks things. It's crazy. Okay, so we're making a copy of the model. So this is just going to be another generator model, and that's fine. Voice crack. You wouldn't believe it. I turned 26 recently. Still having voice cracks to this day. Oh, and then I guess. I don't see. I always find this is unnecessary, this one, but because it's not like you're throwing this into the training loop anyways, but ChatGPT likes to throw this in there just in case you accidentally toss the wrong model into your training loop, as if there isn't obviously some bigger problem that comes with that. The actual updating of the EMA should probably go in a different file. Torch util maybe? There we go. And now we can just update the EMA. So what this does, I guess, yeah, okay. So what this does is it takes the model and it takes the real model and it takes the EMA model and it combines all of their parameters, and one by one, not technically one by one, but like layer by layer, it will it's going to add. It's first going to multiply the EMA one down by some decay amount, which is usually pretty small, like 0.99 or something like that. And then you're going to add this one so that proportionally, now 99.9% of the EMA model was whatever it used to be, and 0.1% of the influence of those parameters is going to be this new stuff. So it's going to be just fine. And then we just run this all the time. Where should we add it? This is definitely my code here, not ChatGPT. I would never use ChatGPT to write my code, nor would I use it for reference or anything like that. PyTorch has an EMA model handler built in. Is that true? I'm gonna ask ChatGPT. Isn't there a built-in one? And it says, yes, PyTorch now includes, here, I'm going to move this over here. PyTorch now includes the built-in EMA utilities, exponential moving average. Oh, wow, that is a lot. That's a lot easier. Yeah, you know, interesting. What? Oh, that's on Torch 2.0. Okay, well, that's been around for a while then. Because we're on like Torch, what is it? Torch 2.7. Amazing. Yeah, that's awesome. Thank you. Thank you, Salty. That is wonderful. Good comms. Love it. Love it. I'm going to delete this file then. We're going to pretend like nothing of that happened. None of that stuff. That never happened in the first place. Torch.ema. Kapow. You know what? Let's put it up with these guys. Torch.ema could not be resolved. What? Yeah, I feel like you're probably more right here. What's the SWA utils one? My link kept getting deleted. Interesting. So if torch.ema won't resolve. You're on a PyTorch version earlier than 2.1. That's not true. Let's see if this resolves. That resolves. Okay, yeah, that's super easy. Great comms. You can look for the example on the PyTorch API website. Absolutely. Averaged model of G. Device. Average function. I don't think I need to pass in the average function. I think it's got it on its own. And then I can just EMA dot update parameters dot update parameters. G. Ooh, wow, that's really nice. I like that. I like that a lot, actually. G, and then we just GEMA there. Perfect. And also, this is not working. I need to end task. Boom. I might just do this with the default. I'm not sure what the default actually is for their decay rates or whatever. But question is this going to be slower? Because it has to do all those updates each time, but I mean, I don't know. When I implemented this in TensorFlow, I did not do it with a pre-built thing, and my implementation was absolutely egregiously slow. It was pretty bad. You guys would make fun of me if you saw it. In fact, I think that yeah, I don't know. 16 batches per second. What's taking so long in between? Maybe. Also, that code might be available still on GitHub somewhere. All right, I gotta go here soon because I have to go and pick up my girlfriend from the airport later. But I'll be sticking around for another at least 20, 25 minutes, 30. Probably till about 8 p.m. my time. Let's see. Let's see how these things are doing. Epoch 3. See, these look like they're not necessarily, what's the word, better, I guess. But they're smoother, right? Like, they don't seem to have as much noise in them, but I don't know, maybe I guess we'll see how this goes from here. Interesting. See, and you can't really tell anything here yet. Like, you can't really say, oh, this one's a horse, this one's a plane. Like, maybe some of them have the patterns of, like, the ones that are in the sky, maybe. The ones that are, like, sky blue are perhaps either boats or planes. I'm going to ask how to change decay the utils. You can't change the decay because it doesn't use a decay. Average model performs a simple arithmetic mean over all models it's updated with. Oh, so but that's not true. Here, I'm going to copy and paste your stuff into, here, let's see. That's not part of official PyTorch, apparently. But, like, I have no reason to not believe you, and I have plenty of reason to not believe ChatGPT in this case. Oh, we've got internal experimental code, apparently. That's crazy that it would say that, but no, I'm not too sure. So yeah, so this is like literally just averaged once per epoch. Okay, so that's not good code. That's not good model stuff. Yeah, so that's the problem is that this doesn't use exponential moving average right now. And I kind of want to just, I still kind of want to just implement it myself. Low key, I'm gonna do it. Then I'm gonna bring back new file, torch utils. I always like having the control over these sorts of things. Strangely enough. Yeah, let's see. And then I'm just gonna import this. I'm just going to use this here. What is SWA? Hold on. SWA PyTorch. Stochastic weight averaging. I think it does use SWA. You're right. Because it's part of SWA utils. But I think it was just like the average over time. Like as the model was training, it was like, here's the parameters for this epoch, here's the parameters for the next epoch, and then it was just taking from each of those and creates just an average of the model completely over time sort of thing. Let's see. I kind of like this anyways. I like implementing my own stuff for a lot of these things, even though I think it might be slower, but it makes me like more or less understand what's going on under the hood. I also don't like having a super high decay ratio, because then I feel like no module name training. Yeah, of course. Yeah, I just like having control over it. It just always feels like I know what's going on if I'm the one who implemented a bunch of these things. Now, of course, I don't know how to implement, convolution as good as the people who make PyTorch. I don't know how to make any of that stuff as well as the people who make PyTorch or TensorFlow, because I'm no crazy CUDA developer kind of guy, and I don't really strive to be. So I think that's okay. I'll leave those things to them, but like for the most part, when it's simpler things like EMAs and stuff like that, I implemented modulated convolution in one of my old videos and stuff like that, just because, well, first of all, they didn't have that in TensorFlow at the time, nor do they have it in TensorFlow at all right now, as far as I know. But it gave me a good sense of control over the code. PyTorch version is 2.7.1, unless some weird stuff happened. Let's see. Pip list. 2.7.1 for CUDA 12.6. I think my CUDA is actually 12.1 on this computer, but I've never seen it go wrong. Let's see here. We're done 3 epochs. Slowly starting to come into its own, but this EMA is very slow. So here's what I'm going to do. Stop this from training. And how about this? I'm just going to give it a little hack here. If epoch is equal to 3, let's say, then we're just going to start the EMA over again. Actually, let's do less than or equal to 3, just so we can see some of the results right off the bat. I feel like that's going to be really nice. And the reason why I did this is just because when the model starts off, maybe it changes its weights and parameters, and maybe it changes them drastically. But typically after a couple epochs, you're not going to be having those same drastic changes. And so these parameter updates are going to, especially the averaging, is not going to have to take like 10 epochs to get all the way back down to the parameters that it needs to be at. Because at epoch 2, 3, we just forced it back and that sort of thing. So this first one's going to be not super great, probably, as you can see. But this one now that's looking good. I like that. That's looking really good off the bat. And now we wait for epoch 3. Does that say, so when it says epoch 3, yeah, it's always +1. Okay. So we still got one more reset. That's going to happen, but here, I'm going to move this so that you guys can take a look here. Starting to get pretty good. I can definitely tell what each of those are. You can tell that the top right one is an airplane, and you can tell that the bottom right one is actually 2 airplanes. The bottom left one is a boat, and the top left one is your mom. Yeah, it's looking not too bad. What I'd really like to do, it set the fixed noise there, but I could swear that it set it somewhere else. Yeah, so this is the problem here, is that when I asked for the code update earlier, it just did that. But now I can do this, and I get rid of that. Boom. Okay, sorry for stopping it so much. I know that you guys are intently watching, but I personally want to see the comparison between training epochs. I want to see it as it like slowly converges. I think that's one of my favorite things about machine learning, is watching as the model slowly converges in on the way that it's going to be, or on its like final output, on its final parameters, those sorts of things. I love watching them converge. I think it's such a cool sight to see, as the model just slowly reaches the point that it wants to reach. It's beautiful. It's one of my favorite parts about machine learning in general, honestly. It's just seeing as those things play out from epoch to epoch, from data set to data set, those sorts of things. Oh, where did it go? There it is. Yeah, so see, now you can start to see, I don't know how to describe it because obviously these look very different, but you can sort of see in the structure of them that when you go back and forth here, boom, you can kind of see in the structure of them that, like, let's take this one for example. I'm not sure if you guys can see my cursor, but it's like the middle and the second last row. That one, it sort of has the same structure a little bit. I don't know. You can, it's interesting to see them like slowly come into shape, slowly add all of the details that it's going to add and stuff like that. So now we've got epoch 5. I think, I'm just trying to think of what else I'm going to add tonight. Let's think. We should make a to-do list, honestly. This sounds like fun. New file, to-do.txt. Okay, so we definitely need style-based generation. We can start with adaptive instance normalization. Then we can go to modulated convolution. We need, we're gonna need StyleGAN 3 stuff eventually, but I'm gonna put that down there. So we're gonna need, constant input. And then we're going to want to reach the unknown. Let me add that. Okay. So It's going to want constant input. I'm going to skip over a bunch of the stuff like path regularization and mixing regularization and regularization. All those things aren't really used in the more modern models. I don't really like them anyways, so for this we're going to want the weird Fourier inputs as constant inputs. I think is going to work fine. It's got like an affine transformation or something like that. But okay, let's look here. Not torch details. We are looking for modules. Class. Adaptive instance normalization 2D. Is that a thing already? Oh no, what have I done? Shoot, eh? Oh, this is why you can't change code when you're training things. Well, I guess we're just gonna have to... It's got a lot of weird red spots going on. But see how you can like sort of follow it along for each image? See, that's one of my favorite parts. It's just seeing as it slowly changes over time. Okay, let's implement adaptive instance normalization. Is there already something out there? Adaptive instance normalization. Adaptive normalization. Here we go. No, they actually don't. They don't have adaptive instance normalization, and I could probably find an implementation. In fact, there's almost certainly implementations of it online, but I don't want to do that. Neural network.module. All right, we're gonna start. All right, so it's gonna be for some dimension. What loss function are you using? I think it's just like the standard GAN one, like cross entropy or something. Binary cross entropy, yeah. Binary cross entropy, and that works really well on sigmoid outputs. I forget how it works. I always get confused as soon as you start adding something like a log or an exponent thing into a layer. Okay, so this is going to take an input. Your input is going to be batch, dimension, width and height. Or maybe it's height and width. I don't really care, because we're basically just doing this on square images anyways, so that's fine. What do you want to have? How do I set up weights? I'm going to ask ChatGPT. In PyTorch, I'm making a custom layer. How do I set up custom parameters, custom trainable parameters? E.g. tensor of 64. Trainable parameter that will automatically be included in model.parameters. Yes, neural network.parameter. Okay. Neural network.parameter. Oh, but you need to send in, because you're not just, this isn't just instance normalization where we are just tossing in. Oh, this is going to be interesting. How? So, okay, sorry, I didn't explain that super well. Obviously, this is not just instance normalization where you are training where you're normalizing and then you're training it to always give a new mean and standard deviation. This, you're normalizing it, but then you're also passing in the new means and standard deviations that you want to have. So there is no trainable parameters technically on this. Now it's an interesting one. There will be trainable parameters, but it's not going to be the way that you probably expect. But yeah, exactly. Linear layer, because we're going to have a linear layer, and then that linear layer is going to determine the new means and standard deviations. Okay, let's do that. New means. You can kind of tell that I am now getting in a little bit over my head just because I'm not using whatever terms they use. I think they use like gammas and betas or something like that. So we're looking for new means. Means FC. You know, that worked out. Linear. I know that they use W for. They use 512. I kind of just want to do 64. You know, I can just set it later. So this is the style dimension. It's just going to be your batch size times style W is BWDIM. So then what we're going to do is we're going to, from there, determine from this style what the new means and standard deviations should be for each of the channels. So we're going to start at WDIM. We're going to end up at dim. Self dot standards. And then what we also want, we don't want these to be negative. We don't want these to be 0. We're going to, I like soft plus. I've always been a big soft plus guy. Means can be anything, I think. Yeah, means can be anything, but standard deviations have to be positive. And you know, their variances technically, but okay. So that's your fully connected, and then let's do, I can't do leaky relu. It's gonna be soft plus or nothing. Threshold 20. Okay. So now we need forward self input torch.tensor. And then we're outputting another torch.tensor. So input's going to be batch dim HW. Okay, so new means can you just pass in like this? I think you can. You just pass in multiple things. New means equals self dot means FC on W. So it's going to be B dim. New variances equals self dot what I call it though. Of course. B, then you're gonna add your dimension. Wonderful, okay. So now you normalize. So you're gonna wanna get torch dot mean. Is it torch or do I use functional here? I'm not sure. On your input, and you're going to want dimension equals minus 1 and minus 2. Keep dim equals true. I'm just going to call these standard deviations and use standard deviations. I'm going to ask ChatGPT first, though. I forget if it's standard deviation. Instance normalization, you should divide by the standard deviation. Okay, sounds good. Then it gave me a really long answer after that, but I am not listening to that. ChatGPT cannot make me read what it has to say. Cool, so standard deviation. Standard mean. Does this give both? Oh, you know, that's pretty nice. Calculates the standard deviation and mean over the dimension specified. Can be a single dimension, list of dimensions. Cool. So I don't even need this. Standard deviations and then old means. X equals INP minus old means. And then divided by old standard deviations. Then we're going to run return. And we want to unsqueeze these two, hey? We're going to see if this works. I mean, maybe we won't, but I feel like there's a better way with the view. Dot view, okay. VC11, okay, and now it's okay, that's easy enough. I'm just going to toss this in here. But these should be new standard deviations. Plus, I don't know why that's showing up all weird. But it is. And now it's fine. Okay, so that should be everything, maybe, perhaps. I'm gonna take this, I'm gonna copy, I'm gonna call it StyleGAN. Yippee! So, I want a generator, but I also just want a mapping network. And I want my generator to take in just the style, just the W. Now this mapping network is going to be insanely fast. It's just going to be self.net equals and then dot sequential. And now here's what we're just going to do. We're just going to add a bunch of forward convolutions and leaky reloos. That's literally gonna be it. That's gonna be all that we could possibly ever want. Yeah, I don't need to do that. We're gonna keep this zdim. Okay. Neural network dot linear zdim 64. Then we're going to add leaky relu. Wait a second. How did I do this before? Self dot. So there's a neural network dot 10h. Oh, it's because I didn't do that. Now we're just gonna do this a couple times. I've never been the biggest stickler for doing it like 10 times. And then we're not gonna do this for the last one, I don't think. Yeah, no, we're not. We don't need to. That's gonna be fine. So basically what we're doing here is we're sending it through a couple layers so that it can, you know, unnormalize the noise or whatever. It can denormalize the noise into some sort of style signal, and then we can just feed that in. So what we can do here is the ZDIM gets passed in. We're not gonna do that. We're gonna pass in a W, and that W is gonna be 64. Also this is just gonna be self.net Z, except that I also want this called input, INP. Cool. So now we're gonna change our generator block. We're gonna take this. We're gonna change generator block to be style generator block. Ooh, style generator block. Cool, cool, cool. Isn't this super awesome? And what we're gonna do is we're just gonna pass in our input, but we're also gonna pass in our style. Torch.tensor. Now I'm gonna look at the old StyleGAN paper to find out what order they did all of these things in, because I can just copy them. Not copy, but you know what I mean. Like, we're going to utilize the things. They added noise. I don't like adding noise. I'm not the biggest fan of adding noise. I don't think it's all that good. Yeah, so they start with a constant. Should a guy add some noise? It's technically relevant in this paper. I'm not going to add noise. I've decided that I'm not going to add noise. I don't think it's necessary. Not for now. Remove traditional input. Yeah, it didn't really help all that much. It adds texture, right? It adds texture. But really you don't need it, right? So, okay, so we're looking here. In each block, you start with an upsample. Fine, we'll do that outside the block, I'm thinking. Yes, good. Very, very good, yes. Constant can be implemented with neural network dot parameter, yeah. And then it can just learn it, which is really convenient. I remember having it was such a pain to do that in TensorFlow. PyTorch honestly just makes it super easy. Also, I'm just looking at the time here. I was planning to get off at 8, so I think I'm just going to implement this really quick. Probably not going to test it, and then I'm going to head out. So it's going to be convolution, adaptive instance normalization, convolution, instance normalization. So what we're going to do is we're going to use convolution. We're not going to transpose. We're not going to use any of these things because I don't think we need to. Okay, so we're gonna do convolution 2D. Gonna be kernel size 3 always. Stride 1 always. Padding 1 just so we don't change the size. Okay. Also, is there another thing for padding mode? What are the other things for padding mode? I don't know. We'll worry about it later. We don't want batch norm. Self.ada in minute of adaptive instance normalization 2D. Your W dimension is always going to be 64, and your dimension is going to be your out dimension. We're just going to do this once, because then you can just do boom, boom kind of thing. Are you planning on using mixed precision training? Oh yeah, absolutely. They can do it. These GPUs can do it. And it speeds things up a lot. I'm probably going to do that as soon as the speed starts becoming kind of annoying to me. So far, it hasn't yet. Can I just pass in this like this? Or is that not allowed? I think it should be allowed. I don't see why it wouldn't. Okay. That's fine. This just gets passed in. Okay. I don't think I have the time to finish this up right now. I probably won't be streaming again tonight, but maybe I'll stream again later this week if you want to come back and hang out while I continue taking this from DCGAN to StyleGAN to StyleGAN 2 to StyleGAN 3 to StyleGAN XL to whatever else it might be in the future. It's going to be a bit of a longer journey. We're going to make it there soon, so it's going to be fun. You unpack your input. Oh, so I have to pass it. So I have to pass it in like X and W equals input. And then for here, I have to do the same thing. X and W equals input. And then here, instead of input, I do X. And W stays the same. And then here I can pass it in as a tuple. That makes a lot more sense. That's very smart. Thank you. Anyways, I'm going to end stream now. It's been a hoot hanging out. Made some pretty good progress, I think. We've got some nice, pretty images. I like it. Thanks for sticking around. All right. See ya.